Greetings, my dear students. I welcome you to another lecture of Circuits and System. In today's lecture, we are going to study synthesis of the signal. So we'll start with the basics of synthesis and we are going to go all the previous year questions today. Students, always remember, success is the sum of all the efforts repeated day in, day out. So you have to keep your hard work going on every day. You don't skip that. So with this motivational quote, let's start with the lectures of synthesis of a signal. Now, what is synthesis? Synthesis is we are given a waveform, we have to determine its mathematical expression. So, in synthesis, we have to determine for any given waveform, we have to determine the mathematical expression. So, for that, we are going to use two basic waveform. One is u of t, that is 1 for t greater than equal to 0 and 0 for t less than 0. And another waveform which we are going to use is R of t, that is t for t greater than equal to 0 and 0 for t less than 0. Okay, so we just have to see a different notation, not the different notation, but an alternate notation to determine R of t. So R of t is defined as t ut, and if we are shifting this signal, let us say I'm shifting R of t by 1, then remember this thing, it would be shifted in both the t in the equivalent representation. So if you remember this thing, this will always help you. And another thing, if there is a change of slope, let us say there is a slope of a, then this a will be multiplied over here. So in this synthesis of the signal, we are going to synthesize each and every waveform which has been given in the previous examination. So let us start with the first example. Now here I have a waveform. So there is a simple trick to it. A simple trick is observe the change, know the amount of the change and write down the equation. For example, let us say in this given signal, there is a change of amplitude over here which is of plus 5. Again, there is a change of amplitude over here. Again, it is of plus 5. Again, there is a change of amplitude over here. Again, which is plus 5. Now, moving down, we have a change of amplitude that is minus 5. Change of amplitude that is minus 5. Change of amplitude that is minus 5. Now, first thing is we have observed the changes in the amplitude. Second thing is we need to mark the position where it has been changed. So it has been changed at t is equals to 0, 1, 2, 3, 4, 5. So these are the 5 points where my amplitude has either risen by 5 or dropped by 5. Okay, so start with the first one. At t is equals to 0, we write u of t, which is 5 times u of t. At t is equals to 1, the signal has been shifted and there is a rise of plus 5 u of t minus 1. At the second point, again there is a rise of 5. So we write down plus 5 u of t minus 2. So we have reached this point. Now my signal is going here. Now suddenly at this point, my signal is dropping by minus 5. So we write down minus 5 u of t minus 3. Then again there is a drop. It is minus 5 u of t minus 4. Then again it is minus 5 u of t minus 5. So these are the points. See, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. 3 times it has risen. Plus 5, plus 5, plus 5. 3 times it has gone down. Minus 5, minus 5, minus 5. Now, if you can observe something, when a waveform is being synthesized in the form of ut, and it is a closed waveform. It started from 0, ended at 0 in terms of amplitude. The sum of all the coefficients will be 0. Sum of all coefficients will be 0. So plus 5, plus 5, plus 5, minus 5, minus 5, minus 5. All right, student. So this is the synthesis of this particular waveform. Now moving ahead, there is another question. Okay, now start observing. Again, we'll go with the same logic. There is a change at 0, there is a change at 1, there is a change at 2, there is a change at 3, there is a change at 4, there is a change at 5. At 0, my waveform has risen by +1. At 1, it has dropped by -1. 2, it has risen by +2. 3, -2. Again +1. Again -1. So what we go? Let's start. So u of t is at 0 minus, because it is going down, u of t minus 1, again going up, plus 2 u of t minus 2, minus at 3, 2 u of t minus 3, 4 going up, plus u of t minus 4, 5 going down, u of t minus 5. Is it clear, everyone? So it has gone bit there. So I'll just write down the last term is u of t minus 5. Okay. So this is the synthesis of this waveform. Now, dear student, there is a question which comes, synthesize the waveform in terms of Laplace transform. So for writing the Laplace transform, when we'll be doing the Laplace transform, we'll revisit all these examples and we just have to convert these terms into the Laplace transforms. Okay. So this is basic synthesis in the form of UT. Now moving ahead, when we have to go with a ramp signal. Now, firstly, we'll just take down this example. This is the simplest example of a ramp signal. Now, we have to go through and follow the same steps as we did in the case of UT. So, see the point of observation. There is a slope, there is a rise of signal in the form of slope, and slope of this signal is +3. Now, from this point till this point, now slope of this signal is -3. So we have got the two changes. Do not forget, this number line starts from here. There is a change over here as well. Here, the slope is 0. And also remember at this point, again, if this number line is going on, here also the slope is 0. That means there is no signal over here, there is no signal over here. And even if it is there, the slope is 0 or amplitude is 0. So we start from this point. At this particular point, my signal is rising in a linear manner, that is r of t. And what is the slope? That is 3r of t. Plus or minus, we'll see over here. At this point, my slope was going on at +3 and suddenly it has been tilted to -3. So what is the amount of change? Now here you have to determine the amount of change. Now what is the amount of change? My amount of change is final slope, that was -3, minus the initial slope, that was -3. So what is the delta? That is the change. I'll just write it down separately. So for this, I'm writing it over here. Delta, that is my change of slope. It was final slope, that is -3, minus the initial slope, that is +3, minus the initial slope, that is +3. So it goes to, delta goes to -6. So this is the change in slope. So I have to write down the change, -6 r t minus 1. So at point 1, there is a change in the slope which is at -6. Similarly, moving at point 2, at this point, my slope, again I'll calculate the delta. My final slope is 0. Initial slope was -3. Minus of -3, this will give me 3. So it will be +3 r t minus 2. This is this waveform f of t. See clearly? Change of slope, 0 minus +3. Oh, 3 minus 0 is 3. So change it. Slope is 3 over here. -3 minus +3 is -6. 0 minus of -3 is 3. So I've written all the changes. So basically, if I have to write down a generalized term, what I've written f of t as delta RT plus delta RT minus 1 plus delta RT minus 2. So what is this delta? Delta is my change of slope, that is final slope minus initial slope. So if I'll talk about delta D, delta 1, delta 2 and delta 3 in this particular example, my delta 1 is nothing but final slope was 3 minus 0, that was 3. So I've replaced it by positive 3. Delta 2, final slope was minus 3 minus the initial slope was plus 3, it will be minus 6. I replaced it by minus 6. And delta 3 is final slope was 0, initial slope was minus of 3, minus of minus 3, should be 3, I'll replace it by plus 3. So this becomes my synthesis of this waveform. But at times, examiner asks you to write this form in the form of ut. So you just have to replace this with ut, 3 times of ut minus 6, t minus 1, ut minus 1 plus 3, t minus 2, ut minus 2. And further also you can simplify it, that is in your hand. Just open this t minus 1 bracket, open this t minus 2 bracket, solve it and write down the most simplest equation. So this is how we do a synthesis of the signal in RT. Let us try another example. So this is the question which came in GGSIPU. Again, firstly, observe the change of points. 2, at 2 there is no change. 3, there is a change, but it will still be a continuing change. At 5, there is a big change. Now here, you have to just see the observation. There are two slopes, and then there is a rise of amplitude at the same point. So let's start with the 0th point. So at 0th point, my slope, I'll just write down f of t, final slope. If it is rising at Vm at 0, so it would be Vm RT plus or minus, we'll see. We have to find out the delta. If this is Vm, this is Vm till I have to just find out the slope. So Vm minus minus of Vm, that is a change in my y. 1, 2, 3, 4. There's a 4-point change in my x. So my slope of this portion is 2Vm by 4, that is Vm by 2. So my slope is Vm by 2 and in negative direction. So there's a change over here from here till here. What is the change? My delta over here is final slope, that is minus Vm by 2 minus of initial slope, that will give me minus 3 by 2 Vm. So it is minus 3 by 2 Vm R t minus 1. So it is over here. Now we have reached this point. Now at this point, there is a sudden jump. You can see there is a sudden jump. So what is the jump? Jump is of minus Vm. So it is Vm u of t minus 5. But if you observe here, there is a slope of 0. Still, even if there is a signal jump, agar wo yahan tak jump bhi karega, again it will start continuing. So this slope of 0 has to be neutralized. So again, there is another term which will come over here. That term will be, what was the slope over here? Vm by 2 minus Vm by 2. Final slope is 0. It would be Vm by 2 R t minus 5. Observe it carefully, my friends. This is a point of observation. If you want, we can say it once again. See, at this point, my signal is rising with a slope of Vm and it is rising linearly. At this point, there is a big change in slope. I've calculated the delta to be minus 3 by 2 Vm, that is Vm2 minus this. I've got this at this point, there is a sudden rise of amplitude Vm. So I have introduced my u of t, and now my slope is getting 0 from what slope? From this one. So I've just introduced an opposite signal to it, that is Vm r t minus 5. So we just have to calculate the form in the form of RT, and then we can convert it in the form of UT. So again, if I have to write the complete equation for this, f of t is Vm t ut minus 3 by 2 Vm t minus 1 u of t minus 1 plus Vm u of t minus 5 plus Vm by 2 t minus 5 u t minus 5. Now solve the equation further. See, Vm2 minus 5, here also it would be there. So solve it, you'll get the final answer. So before going into the synthesis in the form of Laplace or Fourier, try to bring this equation to the simplest form. Okay, so moving ahead. Now again, we have a question. So synthesis of sawtooth waveform. This has been asked many a times in the form of you have to synthesize this form in the form of Laplace. So let us see what are the change of points. We have a change of point over here. We have a change of point over here, change of point over here, and change of point over here. Slope is getting 0. So what is the slope over here? Here the slope is V naught by T down by V naught. Slope of V naught by T down by V naught. Slope of V naught by T and down by V naught. So let us start with the first point. So f of t, let's name it as f of t, is nothing but V naught by T RT plus or minus V naught uh, 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 V naught coming down u of t minus capital T. At this point, again there is a rise plus V naught by T R of t minus T minus V naught u of t minus 2t plus V naught t R of t minus 2t, and last point minus V naught minus V naught u t minus 3t. Remember this point, we have to negate this also, minus, because at this point slope is 0 and it is rising. So final slope V naught minus Vt. So final slope will be 0 minus this, 0 minus this. So that would be minus of V naught by T R T minus 3T. Clear everyone? So what are the change points? 1, 2, 3, 4. At this point, there will be a drop, there will be a rise, there will be a drop, there will be a rise, there's a drop, and we have to put it as 0. So see it carefully. First point, second point, a drop, a rise, a drop, a rise, a drop, and making it 0. So now you know how to replace RT by UT. Just replace RT by UT, you'll get your answer. 1-9 and synthesis is all done. Let us start with this one. Okay, let's start with another example. point of change at this point of change at this point. There's a drop and there's a change of slope. Remember this thing, drop and change of slope. So this is a change of point. So let's start with this one. So this ft can be written as slope. It is rising by 2, change of 2 in both x and y. 2 divided by 2 is 1. So it's r of t. At this point, there is a sudden drop by 1, minus 1, u of t minus 2. Now, at this point, there is a change of slope. Slope is 0. So, 0 minus the initial slope. My initial slope was 1. It would be minus 1. So, it would be minus RT minus 2. That's it. Done. So, simply we can write it as TUT minus UT minus 2 minus T minus 2 UT minus 2. Now you can solve it, you can write it down in any form. Clear everyone? This is the synthesis of the shape form. Let us try another set. Now in this set, this question has been asked multiple times. This question has been asked multiple times. Once they have asked this. So these two are just coinciding with each other. Try it once. Observe the point where there is a change of slope. Observe the point where there is a sudden dip or a sudden rise. Observe the slope. That's it, you're done. So we'll go with this question again. Now at point 0, 1, 2 and 3 there are changes. At 1 there are two changes. 1 it is dropping down. Other slope is getting 0. At 2 there are two changes. So at 1 I'll just write down. At 1 number of changes are 2. At 2 number of changes are 2. At 3 number of changes are 2. At 1 there is a 1 change. So you can just count down the number of equations you will be having, the number of components you will be having in your equation. So you'll be having one component for this, two for this, two for this, and two for this. Let us see. Not two for this, one will do. Yeah, one will do. So we'll have 1, 2, 2, 1. Let us see how many we have. So at t is equals to 0, ft is nothing but it is rising. So there is a change of 2 by 1, that is 2, 2 rt. At point t is equals to 1, it dips by 1. So we have my u minus of ut minus 1. Slope is getting 0. Here the slope is getting 0. Here the slope was 2. So final slope minus the initial slope, it would be minus of 2 t minus 1 r t minus 1. And so finally at t minus 1, I've got the two equation t minus 1, t minus 1. Okay. Now moving ahead. At 2, it is rising by 1. So it is rising by 1, u of t minus 2. And there's a change of slope. The final slope is going down by minus 2 and it was 0. So it would be 0. Final slope is minus 2. 0, 2 minus minus 0, it would be minus 2. So it would be minus 2 r t minus 2. At 3, slope is getting 0. So final slope was 0. 0 minus minus of 2 would be plus 2 plus 2 r t minus 3. So I've got all the equations. So how many terms I've got? Let me just see. 1, 2 for t1, these 2 for t1, 2 for t2 and 1 for t3. See, you just have to observe the point of change. Rise, fall, increase, decrease. Observe that point. How many changes are there at that simple one point will let you know the number of components in your equation. So now I can write this thing as 2t ut minus u of t minus 1 minus 2t minus 2 u of t minus 1 plus u of t minus 2. Then I've got 2t minus 4 u of t minus 2. I forgot to write RT over here. Yeah. Okay. Okay. Please. Plus 2t minus 6 u of t minus 3. So this is the synthesis of this waveform. Finally, the last waveform. Now, this is an interesting case. This also have been asked with you. This is an interesting case. Okay. Now, the interesting case is to start. I'll just give you the start. Remember this thing. This is point 0. At 0 itself, there are two changes. There is a dip of -2 and there is a rise of a ramp waveform. So, IT in this case will start from -2 ut, then we have got plus. Now the change is 2 to 2, it would be 4, and there is 2, there's a change of 2, so 2 RT. So this is the key over here. It is dropping with the same -2, slope is 2, -2 -2, it would be -4, it would be -4 RT minus 2. At this point, there's a rise. Again, -2 was coming here, plus 2 is going here. So final slope is 2 minus minus of initial slope. It will give me +4. So it will rise with +4 R T minus 4 and so on. So this is the synthesis of this particular waveform. Here, the key point is to observe this point. Clear, everyone? Always remember, we can replace RT by TUT. If RT minus 1 is given or T plus 1 is given, anything is given. So you can write down T plus minus 1, U, T plus minus 1, whatever it is. Okay. So that's it for the case of synthesis of the signal. These are all the questions which have been asked in your previous year examination. Practice it once. For any doubt, do comment us. Thank you. So moving ahead, every drop makes an ocean. So your every effort will help you gain marks, and your effort of liking, sharing and subscribing the channel will help us grow. All right, everyone. Thank you. That's it for this lecture.